Good morning everyone. So this is Aruna. Today I have come up with a new concept about oxidation number. Now first of all, what is oxidation number? Then how do we calculate oxidation number for an element in a given compound? Now let me write a definition for this oxidation number first of all. See, the number of electron gain or lose or share during a chemical reaction. During a chemical reaction is nothing but is called oxidation number. Here in a shortcut way I have written oxidation number. See, in any chemical reaction, so the compound is about to form, in that the element electrons, how many electrons are going to lose or how many electrons are going to gain, so that number is nothing but oxidation number of a element in a given compound. Now let me take an example called NaCl. So NaCl, it's a sodium chloride, as we already know it is a salt, sodium chloride, and it is formed by one metal atom and a non-metal atom, chlorine. Okay now in this compound, if I want to find out, or if I really want to find out the sodium metal oxidation number, means how many electrons either it has lost or it has gained to form this sodium chloride compound, let us see. For example, as we know, what is an atomic number for sodium? So 11. So if we write the electronic configuration of sodium, so in this way, 1s2 and 2s2, 2p6, 3s1. Okay na? So in the last shell we have one electron. Now let us write the electronic configuration for chlorine atom as well. Now here chlorine, so the atomic number of chlorine atom is 17. So if we write that electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. So in the last cell, how many electrons do we have? So we have 7 electrons in the valency of chlorine atom, and here we have only 1 electron is present in the valency shell of sodium element. Okay na? But in general, every 2p6, 3s2, 3p5. So these are the two electronic configuration for the two different elements in a given compound. But here one more note we have to observe and we have to keep in our brain. Every element in the nature, they wants to get stability. Then how do they get stability? See, by getting the nearest noble gas configuration, so they will get stability. Now here in the case of sodium, so we have 1 electron in the valency shell, but in the case of chlorine atom we have 7 electrons are there. But when they really want to get the nearest noble gas electronic configuration, so here in the case of sodium metal, it should lose 1 electron from its outermost shell, because if it loses 1 electron, then it will left with what? It is left with 1s2, 2s2, 2p6. So this electronic configuration is for whom, Nana? So this is a neon element electronic configuration. So neon, already we know that noble gases, what are the noble gases? Helium, neon, argon, krypton, xenon, radon. These are noble gases, as already we have studied in earlier classes. So these are noble gases, and these are very, very highly stable in the nature. They do not participate in any chemical reaction, and also they don't lose their electron, they don't gain any electron during a chemical reaction, because they are inactive in the nature. So here in the case of these elements also, if they get these electronic configuration, these elements electronic configuration, they will be stable. Then how do they get these electronic configuration? See, if it is loses 1 electron from the outermost shell, then the sodium metal electronic configuration will be what is? 1s2, 2s2, 2p6. Then it is an electronic configuration for neon element. So by losing 1 electron from the sodium metal in the valency, then it will get a neon electronic configuration. Then it will be stable in the nature. Then the last electron from the sodium, it will go for which place? So this electron is ready to given this electron with the sodium metal, whatever the element is lost from its valency, it is ready to give the element which are in need, because here if you consider the chlorine, so it is having how many electrons in the valency? Only 7. See, to get stability in the nature or to get stabilized in the nature, it needs more one electron. It needs more one electron. So the electron is taken from the sodium metal. Already the sodium metal is losing one electron now. To get stability, it is losing electron. This last electron is to be given to the chlorine atom. So whenever this chlorine atom getting one electron from the sodium metal, automatically it will become 8 electrons. Then if it is gets one more electron, it has how many electrons? Here it will become 3p6. Then whenever if you see this electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, then this electronic configuration, if we observe carefully, then it is an electronic configuration for argon element. So by taking one electron from the sodium metal, it will get the nearest noble gas electronic configuration for argon, and by losing one electron from its valency, it has got the stable electronic configuration of neon. So in this way, from sodium metal, one element should be lost to get stabilized, and here in the chlorine case, one electron should be gained from the other element, means which are is available, which are ready to give their electron to get stability. Now here in our case, our sodium is ready to donate one electron to get stability. Now here chlorine is ready to take electron to get stability. So by losing and by gaining one electron, these two people have attained stability. So in this way, the both elements got combined together, then they form ionic bond between them. Now here, if we really want write an oxidation number for sodium, then how do we need? Here itself I have written that definition, the number of electrons gain or lose or share during a chemical reaction is nothing but oxidation number. How many number of electrons are gaining or losing in this formation of sodium chloride? Only one electron, yes or no? Now here to avoid confusion, let me write in a proper way, NaCl, okay fine, NaCl I have written. Now here sodium metal oxidation number we have to find out. Now here chlorine atom, what is the valency of chlorine atom? If we look at this two, the electronic configuration of chlorine, so what is the earlier electronic configuration? 3s2 and 3p5, yes or no? If it is gets more one electron, it will become stable, no? Now here whenever any element, if it is really want to stable in the nature, if it is gets one electron, so that electron is to be written as a valency for that particular element. Now here if it is gets more one electron, it will become stable in the nature. Now the valency of chlorine atom is what? So -1 we have to consider. Now here let me write Na plus Cl is equals to 0. In this way we have to write, whenever we are calculating the oxidation number of any element, first we have to write in this form. So Na and Cl, because the neutral atom there are certain rules are given, so I will tell you the rules, so but just let me tell you one example to make you clear. Now here NaCl is to be written in this way, and whenever any compound, when it is in a compound form or elementary form, the oxidation number is 0. Now here Na plus Cl is equals to 0 because it is in the compound form. Now here let me substitute the value of Cl. So what is the valency of Cl? -1, as I already told you just now, because how many electrons are gained to get stability is the valency for that element. Here if it is gets more one electron, it will become stable in the nature. Now here to getting electron, because it is not losing, it is getting, no, so negative sign should be indicated. Now here NaCl minus, in the place of Cl minus I have substituted the value -1 is equals to 0. Now again Na plus into minus, here it will become 1, again is equals to 0. Then if we write this -1 after if it takes this -1 to after equals to, then it will become positive sign, then Na is equal to +1, or else we can also write Na is equals to +1. So in this way we can calculate the oxidation number of any type of element in a given compound. So let me tell you one more example. So by this you can understand how do we calculate the oxidation number. Now MgCl2 I have taken. MgCl2 is also a salt. So to find out MgCl2 oxidation number, in this let me take the element magnesium as finding the oxidation number. Now here Mg plus 2Cl is equals to 0, because in the elementary form or in the compound form it is to be equals to 0. So that's why I have written Mg plus 2Cl is equals to 0, because how many number of atoms are there here? 2 chlorine atoms. That is why 2Cl is equals to 0. Now we need to find out the magnesium oxidation number, Mg plus, so Cl, what is the value for Cl? Just now we have known, that is minus 1 is equals to 0. So magnesium plus into minus, minus 2 into 1, 2 is equals to 0. So magnesium is equals to plus 2 we can write. So what is the oxidation number for magnesium? Plus 2. So in this way we can calculate the oxidation number of any type of element in a given compound. Now if we consider one more problem or one more case, aluminum chloride. Aluminum chloride is also one compound. In this compound, if we find out the aluminum oxidation number, how do we calculate? Now Al plus 3Cl is equals to 0, because number of atoms should be mentioned definitely. Again Al plus 3 half minus 1 is equals to 0. Al 3 into plus into minus, minus 3 into 1 3 is equals to 0. Al is equals to plus 3. So these are the 3 different values of different elements of different compounds. Okay na? So in this way we have to find out the oxidation number of an element in a given compound, and there are certain rules. So if we follow the rules, it is very convenient. It is very convenient to calculate the oxidation number of any type of elements. Okay na? So in the next video we will go for learning what are the rules to find out an oxidation number. So how do we calculate for different compounds or like complex compounds? Let us see in the next video. Thank you.